If you'd like to learn how to make sliding walls that can push your player around in your obby, keep watching and I'll show you exactly how to do it. Welcome to Roblox Snippets. Alright, we're going to make the sliding wall example that I showed you at the beginning, and I must admit this is about the third time that I've come up with a better way of doing this. Originally I was using Tween service, however that involved when you move the model around in the workspace you had to change a bunch of settings and it was quite fiddly. So we're going to use prismatic constraints, which are also a little bit sort of fiddly in terms of getting them right, but once you have them working correctly, they'll work very well, and I'll show you different ways to use them. So to get started, if we come up to our Home tab, and we're going to create a part in the workspace, and I'd like you to change the name of this to be a slide part. And down the bottom, we're going to make this is the rock wall. So if you want to pick a color, I'm just going to pick maybe a bit of a darker sort of grey color and change mine to be, say, rock, I think might be good. All right. And then we want to scroll down through the properties and we'll change its size to be 16 by 16 by 10 for now. Now, of course, you can make yours whatever size you like, but just for the purposes of the video, by all means, you can play with these things later, but just stick with what I do here because it's important to make things work properly, all right? And then after you finish the video and you've got a working copy, then you can have a play around with it. All right, so here we have our rock wall that we're going to make use of. Now the second part that we're going to make, actually just before we do that, we'll come down and anchor this rock wall. Actually we'll leave it unanchored because we're going to make this part move, and we'll make can collide stay on because this is the part that we want the player to run into. And I'm going to just rotate it this way so we can work side on. Alright, so now we can right click on this slide part and duplicate it. And we're going to change the name of it to be anchor part. So anchor. Now the anchor part, we're going to change its properties down. We'll make the anchor part anchored, but we're going to turn off can collide. All right. And the only other thing a couple of things we'll do, we'll make this half the size of what this is. So change it to be 8 by 8 by 5. Alright, so and it's sitting in the middle of this part at the moment, and we'll move that shortly. And then come up to the top and make this a red color because we're going to make it invisible eventually, but for now we'll just make it a red color and probably just change its properties back to be plastic. I think might be good. So where is my plastic gone? Smooth plastic will do. Alright, and we can slide that part out, and I just noticed my slide part has changed into roof shingles here, and I'd rather it be rock. Alright, so now we have these two parts that we're going to be working with to create a prismatic constraint. So this anchor part is the one that drives the whole thing, and this part here moves back and forward. So what we'll do is, in the anchor part, come over and click on the plus sign next to it, and in the search box start typing prismatic constraint. Click on it to add it in. Alright, so we've added the prismatic constraint in here. Now the prismatic constraint, if you click on it and we have a look at its properties, so I'll just bring this up so you can see a bit better, has a number of things in it that we can make use of, but if you scroll down a little bit, you'll see that it has attachment 0 and 1. So we need to create those. So back in our anchor part, click on the anchor part and then the plus sign and start typing attachment. When you find it, left click on it and click on the attachment once and then again, and at the very end add a 0. So not a capital O, but a 0. And then we'll do the same thing on the slide part, so click on the slide part, click plus, search for the attachment, left click and add it in, and we'll change the name at the end of this one to be attachment 1. So now we have these two attachments. If we click on our prismatic constraint and scroll down to the attachment section. In the empty box next to attachment 0, left click, and you get this little Lego icon on your mouse. Come up and click on attachment 0, and it'll be added into the box. And do the same with attachment 1. So left click here and click on attachment 1. If all goes well, both parts should get a green outline around them, and you should get a line running between the two parts just like this. If all is going well so far, then we can move on and come down to more properties in the prismatic constraint. So just below where we did the attachments, you'll find we have this slider with actuator type. The drop down box next to it has none. Just left click on it and choose servo, and above that we'll come up with a bunch of numbers that we can play with shortly. And also just below that, where limits enabled, left click on limits enabled, and we'll get some further information that we can change up here. Alright, so just so you can see all of that there, what's basically happening is that this part here with the constraint in it is generating a force and trying to make the attached part, which will be this one here, move to whatever speed that we set using this linear responsiveness. So if you look at the code, the helper text there, it says specifies the sharpness of the linear servo motor in reaching the speed that we set. Now we have these limits, and this will help control how far the part comes out and goes back. Now if I zoom in a little bit on what's going on here, and in actual fact we might just come up, and if you click on the slide part and hold down Command or Control, left click anchor, we might change their transparency up the top here to be, say, 0.8 at the moment. And that way, when we click on the prismatic constraint, it's much easier to see what's going on. Right, so back down where we have these lower and upper limits. So you'll see that if I click on this lower limit and I change this to, say, 2, right, and I click on the upper limit and I change this to be 10, you'll see that the line in here, which if I get a little bit closer, changes a bit, all right? So if I continue to increase this, say to 15, all right, this is where the part will move out to, and I'm talking about the center of the part, so it's from the pivot point in the center of the part. So we actually want this to sort of go up close to the end over here. So let's change it to be, say, we'll try 20, and that's getting close. Now we will play with this a little bit shortly, and we might change this to 1, which is this green ball over here, and it's going to attempt to move between these two parts when we add some code in. Now that we've got these limits imposed on our sliding part, let's come down and have a look at the servo. And now the linear responsiveness, we'll leave it 45. The servo max force, now for now, put in, say, 10,000, and we will change this shortly. So 10, 1, 2, 3, 4. Yeah, we'll leave it at 10,000, so 4 zeros. And let's put the speed in at 5, and we'll leave the target position at 0. Now we're going to add a script to this that will control moving out and moving back. So on the actual prismatic constraint itself, click on the plus next to it, and we're going to add a script. For now, just don't worry about the name of it, because this is just a little bit of a demo to get it working. And inside of here, we'll create a variable, and we'll just call it pris, which will be script.parent. And right below this, we'll create a while true do loop. And we're going to set pris dot, and then we are wanting to change the, over here, the target position. All right, so let's change the target position to equal. Now the upper limit is at the moment 20, so let's set it at that. And right below this, we'll add a task.wait of, say, 2 seconds, and then pris.target position equals, and we'll go to the lower limit, all right, of 2 seconds. So this is going to go run round and round and round. Now let's move back in here, and we'll click on File and Save, and let's play and see what happens. All right. Now, if yours is working, and mine is working, but you'll notice that it's doing some strange things. It's sort of moving slowly and then pausing, etc. So let's investigate a bit and find out what's going on. Open up your workspace and come down to your anchor part and click on the prismatic constraint while it is running in the game. And we'll move in a little bit closer so you can see these bars changing. Scroll down through your properties, and the thing that's changing is the target position, which is what we want. Now what's happening is it's trying to use this amount of force, all right, to get at this speed to get to this position. However, it's not really getting enough time. See how it's already sort of got to here and then went over to here and then back. All right, so we need to play with these figures to get this to work correctly. So stop the game here and let's make a couple of adjustments. The first thing that we're going to do now, if we have a look at the servo max force, I could keep adding zeros on the end of this, all right, and that would work just fine. However, in our script, if we come back to it, let's instead up the top here change the servo max force to a very big number. So we'll say pris dot servo max force, and we're going to use math.huge. All right, and let's set this back to 0 because our script will take care of this, and we'll run the game again. All right, so now it seems to be moving a little bit better. Let's do another little bit of an investigate and click on the prismatic constraint. Now, is it actually getting to where we want it to go? Well, no, because it's running out of time and it's not getting there quick enough. So while the game is running, we can play with some of these settings down the bottom here. Let's change our speed to 25 instead. All right, that's moving much better and it's getting to our constraints. No problem at all. All right, so I wanted to go through that. I have already had these numbers. However, I just wanted to show you how to play with them down here to get them to work correctly. So if yours is moving like that, that's great. And we can stop the game there. And now we know it's working properly. Let's hide our anchor part. So we'll actually make it completely invisible. And come back up to our slide part, and let's make it completely visible by setting it to 0. And we will, we might set, in our script, we're moving to the out position first. So let's set our slide part. If we click on the anchor part, and grab its position. All right, so left click in there and then Command or Control C, and then we'll click on our slide part and paste that position in so that they are on top of one another. And we'll just run the game once it's like this and just check to make sure that it still works correctly. All right, it seems to be moving back and forward as we would expect, so we're all good to go. We'll stop that there, and now that we have this working model, let's change it into a model. So click on the slide part and then Command or Control to select Anchor. Right click on these while they've turned blue and group as model, and we'll call this our sliding wall. Right, and now we can move those around together just like this. Now, what I said before about tween service, now if we had have made this and then it would work where it is, only if I moved it over here or over here, we would have had to go in and change some settings. But by using these prismatic constraints, I'll show you exactly why this is so good. If I now right click and duplicate our model, move it over here and rotate it, or right click and duplicate it again, move it up in the air and over here, and even rotate it on an angle, which we'll turn off 90 degrees and just put it on a strange angle. Let's run the game and see what happens. Alright, now as you can see, all of those are working exactly how we programmed them, regardless of whether I rotated it, moved it, put it in the air, etc. So you can see how powerful that is, and that's just what we want. Alright, so if yours are working just like that, we can stop the game there, and we'll get rid of our couple of other examples. So we've got one sliding wall, and now we're ready to make another wall for this to slide out of in the next section. Right, now that we have this single sliding wall here, this is very usable in your own projects. So if you want to save this before we move on, because we're going to remove the script out of our model, you can come over to your model of sliding wall and right click on it, and then come down to Save to File and left click, and it will save it on your computer somewhere. I've created this resources folder, but you can put it on your desktop or wherever, and I've already done this once, so I call mine single sliding wall, and it is an RBXM file, so that's right, and come over and click on Save, and I'll just replace that one. And when you want to use that again, open up your own project, and all you simply need to do is, if I come up to Workspace and right click and come down to Insert from File, you simply find the model, left click on it and click on Open, and as you can see, it gets put straight in, and if we play, that should work straight away. There they are. Sorry, they're working together, one on top of one another. Alright, so that's how to do that. So if you're happy with that, just we'll delete that one out. But if you'd like to keep watching, I'll show you how to make this slide out of a solid wall, and we will also control multiple walls with one script. So to do that, come over, just leave your model where it is here at the moment, and we'll move over to the right or left here and come up to Home, and let's create a part, and we're going to call this our wall. Alright, and our wall can be, you can leave it just as it is. I'll just make it another color, and let's make it, I might make it a slate. Alright, slightly different to what the our sliding wall is. And if we scroll down, we want to make this anchored, and we also want to have Can Collide set to on. Now we'll scale this up and make it bigger than what our sliding part is. Alright, and come across this way, and we'll resize this shortly. Alright, so just make sure it's bigger than what our sliding part is, and we'll move it over sort of next to where our sliding part is, like this. Okay, so if this is going to be our wall here, alright, then we're going to make a hole right through the middle of this new wall part here for our sliding part to sit in. So if we come down to the size now of our new wall part, let's make the X to be the same size, so we'll say 16. Actually, we'll leave that, say we'll make that 20. Let's make the Y a bit taller than what this is. So we made our Y at 10. So let's make this one at, say, 15 or even 16 high. Should be okay. No, we'll leave it at 20. There we go. And we'll make our Z over here 16 so that it's exactly the same width as this. Right, and our sliding wall model will just move out of the way, but we will make another part like this. So let's duplicate our wall, and we'll change the name of this one to be our negative part, so just NEG, and slide it out here, and we'll make it the same size as what our sliding wall was. So if we look at our slide part, the size of it, you can left click, it's 16 by 16 by 10, Control or Command C to copy it, come to our negative part, and we'll simply paste that in so that it's the same size, and we'll rotate it. Right, now we need to position this where we'd like this to slide through the wall. And we want it to go all the way through, so we'll actually probably scale this so that it's coming out one side and coming out the other, like this. And you want to position it where you want the hole to be that we're going to create. So it could be closer to the ground, maybe up, say, one stud. So if we were to come in here and change this to be 1, and then just move this up one stud off the ground, then it will slide out like this. Now this part is going to be used to cut the hole through the wall here. So we might change its color to, say, a black color so that it stands out. And we're going to use a thing called solid modeling to do this. We want to click on the negative part first. So this is so you remember how to do this. Click on the negative part, solid modeling, and then click on negate. And you'll see that the black part, all right, is now our negative part. And then Command or Control to click on the wall. So you have both parts selected like this. Then come up to solid modeling, and we want to choose union. And if all goes well, you will see that a hole has been made through our wall, and we end up with this union part over here. You also notice that the inside of where the hole was is the same color as the part that we put inside of it. And if you scroll down through the union part now, for example, up the top, if I was to change this color to be blue, nothing happens on our union part. But if we wanted to change that color, you can come down and there's a checkbox here, use part color, and it will use it. All right, just so you know how to do that. But we don't want to do that. We'll just leave it as it is. And we'll change the name of union to be our wall union. So we know that it's a union part. And we're good to go to add into our sliding wall to see if we can get this to work. All right, so let's slide our wall over, all right, our sliding model, and position it inside of this recess here. And we'll slide it back so that it's just, you might need to turn off this one stud at a time just to get it precise. Right, and it's now taken up that hole all the way through perfectly to the other side. So if you have it looking like this, let's give it a play and see if it works correctly. Alright, so now if yours is doing weird things like mine is, which I'm pretty sure it will be, you'll notice that our block is not really moving properly into the wall. And the reason for that is that this solid sliding part, which has can collide on, is colliding with the wall, even though it fits in there perfectly. So the way to get around that is that we're going to make use of collision groups. So if you stop the game running, it is in our prismatic constraint. There we go. All right, inside of here, we're going to make use of the collision groups, and that is part of the physics service. So if we create up the top here a variable for just PS for physics service, which equals game get service and physics service, and then come over to our slide part for a start and left click on it, and down in its properties towards the bottom you'll find this collision group. So we're going to name this group slides. Alright, so any slide, which will be these sliding parts, and the other part that we want it to not collide with is this wall union part that we created. So we'll come down here and find its collision group, and we'll put in here just wall. Alright, so not every wall in the game will need to have this, just the ones that we're working with. So we've got wall, with this one, and we've got the collision group slides down here. So we just need to add a couple of lines of code below our variables here, and we'll say physics service and then a colon, and the first thing we want to do is register a collision group, and inside of here we'll put slides and then physics service, and I just noticed I put rename here instead of, it should be register. So register collision group, all right, register collision group, and we'll put in here wall. And then one line below this, physics service and collision group set collidable, and now we just put in here the two names again. So we want to say slides and then a comma and wall. And do we want them collidable? No. And that's all we should need to do to stop this error that's happening. So let's give it a play and see if it works. Right, if all went well, it should now look much more normal than it was. All right, it's only coming back to sort of, remember that we, in the script here, we set its target position at 1, so it's actually not going completely back to 0, and we've got the other one at 20. So if we were to change the target position in our script to 0, let's see how that performs. Alright, still not going completely back in, but you could adjust that by moving the entire thing sort of back by half a stud to get it perfectly to line up, if you like. Alright, so we now have a working model sliding in and out of a wall. The next part of the video, I'm going to make a bigger wall that has 4 of these, and we're going to control them with one script. Now, you may think that's fairly straightforward. However, controlling how fast and when these come out, there's a little bit of a trick to it. And once I've done that, I'm going to add it into my main game Obby and show you how I add it into a game. And I look forward to seeing you in that section. So let's move on and we'll build the big wall. Alright, we'll build the big model that will have 4 of these walls in it. However, we're going to write a new script, and I'd like you to just click on the script that's in the prismatic constraint for our single wall up here, and right click and cut that. And we'll just come down to, say, replicated storage, right click and paste it in there, and we'll just leave it sitting there. Now we'll right click on it again and disable it so that it's just sitting there not doing anything or interfering with what's going on in the game. So once we have that, just take your sliding wall and slide it out so that it's separate to this other wall here, and we can get rid of that small wall union part and we'll create a new one. Alright, so let's create a part, just a standard part, and you can give it the same sort of settings you did before if you like, with a slate or rock or whatever it is that you might want to use. And we'll call this part wall once again, and we'll come down through its properties and let's change its size, and we'll make it 16, so x16, and we'll make y we'll set as 20, and we'll set the z to be 60. Alright, so we've got a nice big long wall, and bring it up on the base plate here, and we'll just rotate that around so we've got something to work with. Alright, what we're going to do is place 4 of these along this wall here. So if I move this one over here, you'll see we can sort of slide it up here, and we've got sort of enough space in here to do that. So we'll create another negative part that we'll use to go inside of here 4 times. So let's create another part, and we'll call this our negative part. Let's change its color to black, or any color you like really, and we're going to make it, if we scroll down, the same size as our slide part, which will be 16 by 16 by 10, and we'll rotate that around so that we've got a part to work with. And we'll just bring that up like this. Now we'll also come down and turn off Can Collide. Alright, and we'll make it anchored, although it won't really matter. Now the next thing is to position this where you would like the first one to be, and that's pretty good for me, just sort of about one stud up off the ground. And if I move it over this way, say about there. Right now I would like probably about 1 or 2 studs in between. You can pick what you would like to put in between, but let's right click and duplicate this one. And if I come up to model and I'll turn on the move, so if I want to put a gap in between of say 2 studs, then we want to move it across say 12. So let's put in here 12 and then move this across till the numbers change to say 12, and we should have a perfect 2 stud gap in between. And then we can right click again and duplicate, and we'll drag it across till the numbers say 12, and once again do the same thing, drag this across till they say 12. Right, now if it's a little bit out or etc, not in the center, you can highlight all of them and we turn this off. Just move them over till they're sort of in the middle of your wall or they look about right, and that's pretty good, I think. Okay, so now that we have these, we want to use the solid modeling. So click on model and we'll want to come down to all 4. So click the first negative one and then shift to hold and shift and click on the last one to select them all, and then hold down Command or Control and click on the wall to select it as well. Then come up, unselect that. So we've just got the negative one selected. Come up to solid modeling and click on negate. Alright, and then Command or Control and click on wall to select it, solid modeling and click union. And that should take out a recess in our wall. Now you'll notice it doesn't go all the way through to the back, but it should be big enough for us to put this part in here. So let's take our sliding wall and we're going to move it into one of these recesses here. Alright, so just line it up so it snaps into position. And slide it back in. And it just needs to come over slightly. Right, and we should have that just about right. So a little bit tricky to get it lined up exactly, but that should work very nicely now to slide in and out, and it won't come out the back. Now if it does come out the back and you wanted to see that, obviously you can make this wall a bit bigger. But in my case, this is not really going to bother me that there's no hole right through to the back. Alright, let's now take our sliding wall that we put in here, and we want to duplicate this and move it into these other recesses over to the right. So remember, we duplicate this one and we moved across the 12. So if we turn this back on again, right click and duplicate, and then drag it across till it says 12, and do it another couple of times. Right click, drag it across, and right click, duplicate, and drag it across. Okay, so we've got our model sort of looking pretty good. Now the next thing is that we want to have something for the players to run on down here. So we'll create another part, and we'll just say part in here. We'll make it perhaps the same sort of color as the wall at the back. I'm going to make mine rock, if I can find it. There it is. And we'll call this path, and we want to stretch it out so that it's the same sort of length as our part here. Alright, I've got this 12 studs on here, that's causing me problems. Alright, Let's stretch that out till it's about the right length. And let's move this back over to here. We'll click on move and let's move it down slightly. So we're not sort of level with our wall, but not interfering with the slides that are coming out. So if we look at our size now, let's make the X 60. That'll make it exactly the right length, and we'll make the Y 0.5 so that it's a bit thinner. And it's about 8 studs wide, which we can have a play with if that doesn't work out to be quite correct. Now the position at the moment, if we have a look, is 0.5. Let's change that to 0.25 so that it's sitting level with the ground, and that should be pretty good. Alright, let's now turn this into a complete model by selecting and hold down Command or Control and click on these one after the other. So all the sliding walls, the union part, which is our wall, and our path, and we'll right click and group as model, and we'll call this our sliding wall model, so that we've now got one complete unit that we can move around and place it wherever we like. Now the other thing, we'll just make a couple of changes. Our wall union in here, let's change it to be wall. Wall would be fine. And we've got our path, and if we scroll down to our path, let's make sure that we have anchored on, otherwise it won't stay where it is. And we also need can collide on so that the players can run on it. And if we give it a quick play, just to make sure nothing is changed, then everything should be sliding out, which we now have a bit of a crazy sort of sliding out thing going on here. And that is because we don't have a script in there, so it's just moved out as far as it possibly can and stopped. Alright, so let's stop that, and we'll now add a script in here to control how these move back and forward. Alright, to add a script in to control all of our sliding walls, come over to the sliding wall model, click on the plus, and we'll add a script in. And we'll rename this one sliding wall script. In our script, we'll just drop down a couple of lines. Now we're going to, if I just move down so we can look, and expand out each sliding wall that we have inside of here until we can see, and our anchor part, we need to get the prismatic constraints. So stretch these out so that you can see them all. Get rid of your properties window there if you need to, and our last sliding wall with our anchor part. What we're going to do is create what's called a tag script, and we're going to tag each one of these prismatic constraints and then use this script to apply the same code to all of them. Alright, so when you've got them expanded out like this, click on the workspace view and come up to plugins at the top, and somewhere in your plugins here you should find this tag window instance. Alright, now if you don't find that, come over to manage plugins and then have it in, but this is a standard Roblox plugin, so left click on that and you should have a window come up like this. Maybe it's down the bottom, etc. Tag editor. Now inside of where it says add new tag, just click in there and we will call this sliding, make sure you spell it right, sliding wall, and hit enter. So we now have this tag and we want to apply it to these parts. So click on the first prismatic constraint, then Command or Control and hold it down while you left click on the others, like so. So when they're all blue like that, in the checkbox next to our sliding wall tag, left click in there, and when you see a blue tick that has appeared, simply come up and close the tag editor window, although you can leave it there just for the moment in case you forget what you called this, because if we come over and click on the script, we're now going to create the variables to handle that in here. So the first one will be local CS, short for collection service, which will be game, and get service, and in here collection service. Alright, and I'll just get rid of this window Now right below this, we'll create another variable called tagged parts, and it will be collection service and then a colon and get tagged. And inside of here is we want to put the name of the tag. Now, if you got rid of the window and you can't remember, you can come back over and click on the tag window again and it should bring it up. So sliding wall, it has to be just like it's written here. Right, and we'll type that in here. So sliding wall. And now we'll loop through all of these parts. So we'll say for and underscore, which means for however many there are. And we'll say TP, short for tagged part, in pairs the tagged parts. And just outside do. And now we can go ahead and write our script almost the same as what we did before. Now we're going to once again make use of the physics service up the top. So say local PS game get service and our physics service. And just below above our loop here, we'll now register our parts again like we did before. So it's physics service and then register collision group, and it was slides, and then right below this physics group register collision group wall. And if you want to check those, remember that we had wall down here, and if I bring this up, we may, because we created a new wall, we'll have to maybe put it in down the bottom here. So we did, so we can say wall in here. And these others up at the top here, our slide parts, all right, should have that already in them as we just duplicated them. So slides, and then physics service, collision group set collidable, and we'll say slides and wall and false. So now they should all not collide and cause us any problems. All right. Inside of here, because we're creating this for each part and we're using a while loop, we're going to spawn a function that contains all of our code. So type task.spawn, and inside of here type function with a set of brackets. Just move outside the first one and hit enter. So it should look like that. And so that we can get a hold of, if we look at one of our prismatic constraints down here, the first thing that we will want to do is to set the servo max force like we did before. So we'll say TP in this case, dot and servo. Now you won't get any helper text because this part hasn't been created yet. So just be careful, click on a prismatic constraint and check down here that you are doing this correctly. So servo, all right, max force, and it will be equal to math.huge. And then just below this, let's set the other, we're going to make a bit of a change to these based on my testing, and we're going to change the lower limit. So we'll say TP dot lower limit will be equal to 0. We'll say TP dot upper limit will be equal to 12, and then we're going to set our linear responsiveness. So TP.linear, and that's this one down here. All right, so linear responsiveness will be equal to 90, and we'll set the speed, so TP.speed will be equal to 25, and I think that's about all that we need to change for each of these. Alright, so the next thing is, just below this, we'll now create our while loop to change our target position. So while true, do, And inside of here, we're going to say tp.target position will equal 0 to start with. And then we'll say task.wait. And now we'll just put 1 in here because we're going to do something a bit different in a moment. And tp.target position equals, and we'll set the target position at, well, we might change our upper limit up here to 16, and we'll see how that works. And we'll set this to 16 as well. Okay, so we'll try to hit the positions and see if that will work for us. And then task.wait of 1. So once you have this is what we had before, and so you can see the whole script. Right, I'll just shrink that up a bit. Right, so that's the whole script there, almost. Let's click on File and Save, and I'll bring up my output window and we'll give it a play and see if we got it right. Alright, if all went well, you should see all of them are moving in and out nice and smoothly, not jittery or anything. The player cannot run through them, and if I get in front, it's going to push me off the edge. Alright, like that. Well, it's not being particularly pushy, so I might need to choose the density. Alright, and there it is, he's pushing me out. Okay, so let's stop that and we'll work on how can we change so that these are different. Now I'll come up with a little bit of a system to do this, and it'll only take a little minute. Back into our script. Up the top here, just above where we register, we're going to create a little table. So this one will be called pattern 1 equals a set of squiggly brackets, and put in here 1, 3, 2, 4. Now you can make pattern 2, etc. and experiment with this. I did it this way so that you can have a play with it. And right below this, we'll create a variable called index, which will be set to 1, and that will represent each position in this table. Now down in our while loop, we're going to use the table in here, or a value out of it. So pattern 1, and then a set of square brackets, and we're going to say index, and then mod, so that's the percentage sign, 3 in this one, and in the one below this, we'll say pattern 1 square index, and then mod 2. So if you don't quite understand this, mods, if the number that comes in here doesn't return anything, it will, well, I could explain it, but the video is getting a bit long, so just follow along and you can give it a try. And if you come up with a better way to do this, by all means, go ahead. But I've given this a test, and it seems to work pretty well. Now, just below this, because the index, we're going to increase the index each time, we need to reset the index as the while loop runs. So we'll say if index equals 4, which is the length of our pattern up the top, then we want to reset index back to 1, else we'll add, so plus equals 1 onto index, and that will go round and round and keep resetting and making use of our pattern numbers up the top here. Right, so if you've got that in there looking like that, let's click on File and Save and give it a run. Alright, if all went well, you should see that your walls are now moving out in random patterns. So sometimes 2 will move out, sometimes 1, sometimes all of them. And by playing around with those pattern numbers, you will see that you can get some different results, particularly if you change the value down to lower values. So instead of 1, you could use 0.5, etc. The walls will move quicker. Alright, so that's something for you to have a play with and decide how you would like that to work. But if that's enough for you, you can by all means save the whole project and put it into your own. Otherwise, if you want to stick around, I will cover how I add this into my main game Obby next, so you can either follow along and do it if you've been creating your own Obby, or you can just watch and see what happens, because sometimes we run into some troubles when you add into your project, and I'll show you how to fix them up. So I'll see you in the next section. Alright, if you've stuck around, thank you, and this won't take too long. So with our project we've just been waiting on, we should have one model over here, and what you want to do is right click on that and come down to Save to File, and then somewhere in your computer, I've saved mine as Sliding Wall Model in this Resources folder, and it should be an RBXM file. So if you go ahead and do that, I'll just replace the one I had there. And once you've done that, you can close this project and either open up your main game Obby or follow along with me. So I'll pause the video and bring up my main game. Alright, so this is my main game Obby, and I won't go through everything that's in here, only the fact that recently we added a double jump, so I've made a path up to this spot up the very top here in the sky, and this is where we're going to add in our new obstacle of our sliding walls. So come up to Workspace, and I will right click on that and insert from File, find my sliding wall model and add it in. Right, as you can see, it's just popped up down near the center down here, so we need to move it up to where we are. Now with some models you could make a primary part and move it up, but we won't do that today. So that's about right, and we'll rotate this around, say this way. And I'm going to move it out just initially just in front of us here, and probably maybe across this way slightly. Right, and I might just tidy up just one thing there. If I open up the sliding wall model, I've got my path here, which I noticed is just not quite the right length. I'm not sure if it's lined up at the end there or slid over, so we'll just move that over, and that's about right. Okay. And let's move the whole model sort of into the center here slightly. I'm going to move this because the players in this game have the ability to double jump. So I want to move the entire model out about 20 studs. And they should be able to make this with a double jump. So we'll move this out till it says 20. 20-ish. Okay, so we should be able to make that. Now, the way I've created these walls, obviously they could possibly jump up on top of this. So I don't really want that to happen. And in that case, I will add another part in, a roof part, to make them jump onto here. But let's just play the game from here. So this is a checkpoint. However, I'll just come up to Home, and under Play, on the drop down, I'll say Play Here. And I'm in the game. Now, my whole wall was not anchored apparently, and it's fallen on the ground. That was a bit of a rookie error there. So let's just make sure that's not the case, and come down and click on Anchored and see if it works a bit better now. Alright, and there we go. Our wall is shooting out. Now, the path is pretty thin there at the moment, and the walls are coming way out. But I'll see if I can jump over there. So, very good. Now, with my double jump, I can actually jump up on top of here and run along the top. And, which, you know, I can fix that up later. But this also presents an interesting thing to look at, where you could make a path like this, rather than walls, where players have to jump on top of these to get across an obstacle. So there's lots of ways. If you were to turn it vertically, you could make steps that came out different distances that they had to jump up. So there are lots of ways to make use of this, but for now, it's in my main game Obby, and everything is working correctly. So I hope you enjoyed that and got something out of it, and I will see you in future videos. If you found this video useful, subscribe now. For more information about my online courses, go to mrbrendanross.com.